Hey everyone, today we'll be covering how you can use polymorphic data objects in your .NET application, how you can then describe those polymorphic objects in your OpenAPI or Swagger document, and then how you can use something like an OpenAPI generator to generate client-side code that respects these polymorphic types. Fortunately, in .NET with Entity Framework, it's fairly easy to store polymorphic objects in our database because Entity Framework sets a discriminator value for us, so it can tell what object of what type is going into the database when it's saved. The trick is though, once those objects are retrieved from the database and they are returned over the API, how can the polymorphic nature of those individual types be respected as they go back over the API? That's kind of a little bit tricky, and I haven't found anything that definitively showed me how to do it, so I kind of have to piece it together, and then I thought I could share it so other people wouldn't have the same pain that I did. Just quickly though, just to describe what polymorphism is within the context of this video, it's the concept of having a class which might be abstract, for instance, of which the properties are common denominators or might be shared between multiple types. So in the example of a restaurant, if you had a order come in, you would have a database ID, time of the order, and then you might have some other types. For example, you might have a food order, which would include what things were added or removed from that meal. You might have a drinks order, which would include what type of drink was ordered. Or maybe our restaurant is super exciting and people can order mariachi bands to their table. All three of these items have those things in common. They need a database ID and the time of when they are ordered, but they have different specific properties per object. It matters because we might want to save these objects of varying types to our database to be retrieved through the API. So to understand this topic, we'll set up a brand new .NET application with an OpenAPI or Swagger specification, and we'll set up our Entity Framework database as well with polymorphic objects. We'll also configure our OpenAPI document to correctly advertise as polymorphic objects so that OpenAPI generator can generate the right client-side code for our app. And then we'll set up a brand new Flutter project that can receive these objects, inspect the types at runtime, and then render the appropriate widget as needed. For me, I haven't seen a comprehensive way to do this. So what follows is my original research. So it might be a bit clunky in parts. So if you know of a better way to do it, by all means, let me know in the comments.
Okay, so this is my project that I've set up for this sample. So the first thing I want to look at here is the models for this app. So we have an abstract class here of order, which is the base class for the food order here, and also drink order, and also the order for the mariachi band. And then as well as that, I also, for all my classes here that represent objects in the database, I also have an API equivalent. So if we go ahead and skip to that, we can see here we have an order API, which is a base class for our API objects. So food order API, drink order API, mariachi order API. And these all correlate one-to-one essentially with what we have on our objects in the database. So food order API, drink order, so drink order API, drink order, and so on and so forth. So while these have a similar shape in that they have a base class, they're obviously not related apart from that. So what I do as well as that is within my Entity Framework classes, I also have these functions here, which map the objects to their corresponding API equivalents. So on each thing, so here we have the food order, and this is the Entity Framework class, and I have a function here called toFoodOrderAPI. This returns this object as that object, so it maps the database object of food order into food order API, which is what we would receive, of course, over the API. And it's the same for the other classes here as well. And in here, the function for toOrderAPI, because ultimately this could be one of three possible return types, I have this here, which uses pattern matching in C# to figure out the type and return it accordingly. So if it's a food order, then we have that food order object, and then we call the toFoodOrderAPI on that object. Same for drinks, same for mariachi order. So probably one of the last things worth mentioning here is that on a controller, so the controller here is just an API controller. It takes a reference to our Entity Framework database. And here we have a call here for get order with the ID of the order itself. And it's pretty straightforward, just finds the order in the database. If it's not there, then it returns nothing. Otherwise, it gets the API order, which is calling that toOrderAPI function that I was talking about before. And then it returns that API order. Aside from that, I also have a seeding worker, which essentially just seeds the database with test data. So it just seeds with a bunch of these polymorphic data types. And then in our program CS, there's not really too many special things going on. We have here add Swagger gen code, and also the enable annotations for inheritance, and also enable annotations for polymorphism. And we'll have a look at what that means in just a second, but also the call here to use oneOf for polymorphism. So I set up my Swagger document here, and then I set up my database context, which is pretty straightforward as well, and then add in my seeding worker to run the database seeding. The rest of this is the same as any other .NET app you'd set up. And if we run it, you see our seeding work there as all the values get inserted into the database. And we also see here on our get order and go down to schema, we can see that our response here is saying that it'll return one of the following: either a food order with the type, either the drink order, or the mariachi order, for instance, as well. So if we put in 20 and run it, then we'll get back a drink order, which is what we would expect. I put in 50 and run it, then we get back a food order and the appropriate properties. And finally, I put in 80 and ran that, then we'd get the mariachi order as per we would expect. So with all that set up, we actually now have enough to do our setup on the Flutter side and set up our API projects and also our generated code appropriately.
Alright, so now we have our API project set up, let's move on to setting up our Flutter project so we can see how it works on that side. We'll have to configure the OpenAPI project to generate the client-side libraries for our project, set it up to point to the correct URL, and then use a switch case to render the correct widget depending on what type is received.
So the first thing we'll do is we'll go ahead and we'll set up our generated API client. I actually do this through Node because I find it to be a lot easier. So if we go npm init, and the reasons why I do that might become clear pretty soon. So npm init, and I just take all the defaults and then just install that into our project. So save, and then I open up the code package.json, and this is our pristine Node.js configuration. So let's go in here, new scripts. So now let's set up the OpenAPI generator. So if I come into here and go scripts, call it make API, and then if I paste in my very long string, but I'll explain what this is actually doing because it's a little bit long. I'll make it a bit bigger so they'll actually see what's going on. So because a lot of API generation happens over HTTPS, but it's using a self-signed certificate, it can be a real pain to try and get Java to trust the HTTPS certificate, which is how OpenAPI, and because OpenAPI uses Java, it's easier in my case for this application to essentially turn off SSL verification for self-signed certificates. So we see here Java options. All I'm doing is I'm saying for this particular execution to trust certificates here, and also configuring a different function. And then when that's done, I then call the OpenAPI generator to generate the client code, and I'll just have to check that is the. So in this case, it's 5216, so we'll need to change it to 5216. .do is correct, I think, and I need to change this to the current directory. I find out generate it into the API client directory. Otherwise, I don't get good code suggestions in Android Studio. Pub name API client's okay. I'll leave enum extensions and turn off the legacy discriminator value, which helps polymorphism work a bit better. I don't mind ignoring the spec in this case because it's just a test app. And then again, also to trust these self-signed certificates. Once this runs, then I have to actually move into the API client directory and then get the packages for it and then run build runner, because build runner will actually do some code generation that needs to occur. Then format the code and then come back to where I was, but I can get rid of that last CD because that doesn't apply. So on paper now, if I were to hop back into here and go npm run make API, and run my very long string, it'll retrieve the latest OpenAPI generator. and that will produce our API client for our app. And run build runner, and that's pretty much done. So generator's mostly happy. There's a few things it's not too happy about. I get hung up on this discriminator thing type, but the reference schema is incorrect. And another warning, which we can ignore just because I haven't named that particular operation. But aside from that, we now have our API client good to go. So for now in our project, which we've got, our Flutter project, let's go ahead and make this a little bit bigger. Okay. So we can see we have our API client here, which is generated here, and it has all our own generated code that goes into the API client, including our drink orders and also our generated code as well. So now we want to go into the pubspec YAML. We want to add a reference to the API project that we just brought in. We want to add in API client, and then I think it's path, yeah, which is API client. Set, which is just okay. That's okay, that's okay. And we also want to bring in the oneOf package, and then we should be able to hit pub get, and all those things should come in, which is a really good sign. So now if I come into our main directory and make a new directory called home, for instance, and then make up home.dart, and if I have a stateful widget, so, and then I'll call it home widget and bring in all the required things. So the first thing we'll do is we'll have a init state here and have a API client, which can be our API client, which is okay. And base path will be HTTP to I think it's 10.0.2.2 in the, because 10.0.2.2 is the local host through the emulator, and then that'll be on 5.2.1.6 as well. And we have our API client set up. So now, because we have that API client object, okay, API client, we say the food API, and then we can say to get the food order, and int ID, and let's say 10. So ID is 10. Now the response to that is a future of type API food order get 200 response, which doesn't seem like anything we've put in. So, but interestingly enough, if we were to see what happens in there, so see what it actually is, they have X data, and we have oneOf type, which is good, and we have value. But interestingly enough, none of this actually helps us to understand what type this particular thing is. So for argument's sake, what we'll do within our widget build and widget method is we'll have a scaffold, and then we'll have a bar, because why not? And title text will be polymorphism test, and the body of that will be a list. Should be a grid view, and I want to count. Let's go 3 on the cross axis, and then children. So list generate, that could be 100 long to match the 100 items in the database, and this can be the number. From here we can just get a little card. For now, let's just put nothing in there, just to see if it's good so far. Go back to main, update this to home widget trailing slash, and we'll build it. And we can see there we have our 100 cards consisting of nothing, which is pretty exciting stuff. So now if we come back into our widget and we instead say that we want a future builder, our future will be API client, get food API, and the order and the number is going to be the index, so between 1 and 100. And we can have this here, data. So here we can have a future builder, and if there is data, it goes to has loaded, otherwise it hasn't loaded. If I just hot restart this, we can see it goes not loaded, and then it goes over to has loaded once that data's come in. So for argument's sake now, if I go data and data oneOf value type string, and it's obviously the naming is not great here, but if we have in the data object and oneOf runtime type, we can see we have our drink order API, and as we scroll, actually I'll change that to a column and also include the index number so we can see what's going on. Index. So index 6. So we get the drinks order, and then we have the food order. Drinks, and then it goes to food, and then it goes to mariachi at the very end, which is that's what you would expect. So the real problem is that while we know the value at this point in time, the trick of it is getting to render things based on what that response actually is, and conditionally rendering what it is based on what that type actually is. So here in my column, I'll have my text widget still with the index, and I'll switch on the data value. And we know that these will exist because they're polymorphic and it's loaded. And I'll and then within here, we can say if it's a food order API, we can say it's food, and then we can make the right decision. So icons, food, beverage, or if it's drinks, drink order API, drink, icons, drink, drink, and then if it's a mariachi order API, mariachi, icons, and let's say guitar, music. And then the only thing I'll be unhappy about this is it's not exhaustively matched, so we can say unknown type, save that, and what I'll do as well as that is I'll also re-include data oneOf value type to string, and we'll definitely have that, So we can see here now that starting at 0 we have our drink order and our drink emoji, and as we scroll, and it goes to food order with the food icon there, and then before finally going to the mariachi order here. So it's really quite powerful because what happens is within this single build method, we make a decision based on what type's coming in, and it's quite simple, it's quite elegant, and it works really well. The only wrinkle in all of this is that I find that Android Studio doesn't really do well at suggesting what should go here and what type should take place here, so you kind of have to know exactly what your classes are called. But all of these classes here are just generated straight out of OpenAPI. The only other thing is, of course, you can't have it be exhaustively matched. You have to add in a catch-all here as well. But for being able to render based on what's been received over the API, all in all, it's not a terrible solution. And it doesn't require many changes to your Flutter project either, which is also a high point.